How's it going, everybody? It's Eli here from TreeFall Studios. Today I have a very special video for you. One of the first of its kind, actually, because a fan of the channel wrote in and asked specifically for a video request. So here is what he said. He said, "Hello, I really enjoy your videos, but not many people on YouTube do PS4 specific vlogs. I would like to know, how do you do optimization for PS4 hardware? Or how hard is it to get your game on the PS4 if it already runs well on the PC? Thank you and keep up the good work." So today I'm going to tackle that very question. Unfortunately, I can't answer it super specifically according to the PS4 because all companies, whether it's PlayStation, Nintendo, or Xbox, have NDAs that cover most everything that it comes to porting your game to their hardware. But however, what I can answer is general good optimization tips for your game on how to get your game ready from the PC to run on consoles. If you're new to the channel, my name's Eli and I run an indie game development studio called TreeFall Studios. I post all sorts of game development related content on this channel, from devlogs showing the creation of my games, as well as game development tips videos to help you get started in game development. If that sounds interesting to you, be sure to hit that subscribe button. To keep this video easy and simple to follow, I'm going to break down game optimization for consoles into three simple categories. One is going to be the Unity setup, two is going to be asset importing, and then three is going to be coding best practices. With that being said, let's jump into the computer and check those out.
This is by no means going to be an all-encompassing video. It would take too long just to mention everything. I actually recorded so much footage for this video on my first take that I realized it was way too long. So I'm going to break it down to a few simple tips for each category. The first one is the Unity engine level setup. Some of the biggest impacts to game performance is draw calls and lighting. So my first tip to avoid this is use the static checkbox. Marking objects as static allows Unity to perform static batching, which lowers your game's draw calls. It also groups certain objects together, and that does a number of things behind the scenes so your game can run smoothly. This actually leads right into tip number two. And tip number two is to bake your lighting. Real-time lighting can look really cool, but it is expensive in terms of computation, especially depending on the quality of your shadows and how many objects you have in a scene. Baking the light saves your shadows to an image file, and according to Unity, this actually runs 2 to 3 times faster than real-time lighting does. You can use mixed lighting by setting your directional lights to mixed, which allows for some objects to show real-time shadows and others to use the bake light map. The static checkbox tells the engine which objects to include in your light map. Also, be sure to only use one directional light in the scene if possible. Tip number three is use occlusion culling for some scenes. Most of my games don't actually need this because of the way I have the scene set up, but if you have a scene where big walls or objects tend to block a ton of other game objects, you can click on Window, Rendering, and then Occlusion Culling. This pulls up the menu for you. Set the large vision blocking objects to Occluder Static and the little objects to Occlude E Static. Hit Bake in this tab and let the magic work. Don't use this for scenes that don't fit this description, however, because it will actually be detrimental to your performance. Tip number four is use LOD. LOD stands for the level of detail. If you need to, you can make different models that vary in polygon counts, and Unity will render each one depending on your distance from the game object. If you actually name your assets correctly on import, Unity will set this up for you completely without you having to change anything. And the final tip is to know where your graphical settings are. Unity has a ton of settings areas that impact your game's performance. If you are putting all these tips into practice and your game still doesn't run well when you port it to a console, be sure to check your graphics settings, your quality settings, lighting settings, and player settings in order to scale back some of the rendering options for your game. There are a ton of different options to check and choose from, but some of the easiest to change are in the quality settings, and you can change shadow render distance, anti-aliasing settings, shadow quality, and the pixel light count for quick results. Now that we have talked about how to set up your game in the engine, let's talk about getting your assets to the engine. Area 2 to take care of is asset importing. There are a few key things you can do in order to optimize your incoming assets. This will help your game run faster before even messing with the game engine settings. Tip number 1 is to model for the game, not for realism. What I mean by this is to keep your poly counts reasonable, but more importantly, delete any unused or unseen faces. Depending on how your game is set up with the game's camera, you might not be able to see the back of a model or the bottom, for example. So just go ahead and delete those faces. Even though it looks incomplete in the modeling engine, you won't be able to see it in the game view, and it will give Unity less to calculate and less to render. Tip number 2 is to choose the correct export option. Unity accepts a ton of different 3D object files, which makes it super user-friendly, but not all the files are the same. Importing the blend file can be super tempting, as you can just double-click it, edit it, and save it, all from the Unity engine, and have the model update in the game. This might not be the best option, however. If you look at the file sizes in the Windows Explorer, you can see that blend files can be over 18 times as large in my own game. So be sure to export out as an FBX file before you import your assets. The last tip for asset importing is getting the compression settings in the Unity import settings correct. By default, most of this should be set, but in case it isn't, click on Edit, Preferences, and then check the box next to the Compress Assets on Import button. Now for model import settings. By default, there are a ton of things selected, like lights, cameras, and import blend shapes, and if you aren't using any of these, just go ahead and uncheck them. Another thing to keep an eye out for is to make sure that read write is unchecked if you do not need to change the model from code at runtime. This will save you a whole lot of information. If your model file sizes are still large after all of that, you can try turning on mesh compression. There are 3 settings, high, medium, and low. As far as I've seen, importing assets with low compression by default makes an almost unnoticeable difference in the quality of the model, so try setting your objects to low if they're still bogging down the scene's file size. For the texture import settings, be sure to set the max size to an appropriate number. 2048 as the max size is, accepted in most everywhere these days. By editing our preferences earlier, you should see the default compression value in textures to default to normal quality. You can actually change this to low quality if you still have massive texture sizes that need toning down. Another important file reducing tip is to handle your MIP maps correctly. MIP maps are kind of like the LOD for models, but for textures. If you have MIP maps checked, Unity will generate other versions of the texture to display while farther away. This is great for textures on game objects, but this wastes space when you need to render a certain texture at a certain quality. The best example for this is UI elements or the skybox. I found for my skybox textures that I imported, Unity automatically generated bitmaps that were never displayed. So go ahead and uncheck that box. The last main area in your game to optimize is your code. You can optimize your assets in your game all day, but if your code is redundant, you can still slow down your own game. So here are a few of the easy mistakes that I made when I was first learning. Tip number 1, get out of update, only run what is necessary. For those of you who are new to programming or C# in Unity, we have something called the update function. That is called once a frame, so if your game is running at 60 frames per second, all the code in every single update function in your game is going to run through 60 times in 1 second. With that knowledge, you can see why running unnecessary code in here is problematic. A simple example is references. A real beginner mistake I used to make was assigning a reference in update over and over. Let's say your game object needs to find the player. You can find the player in the start function, and you don't need it to update every single frame if you don't delete or change your reference in the game. It's also a good idea to separate your code into methods outside of the update function and use update to call those methods for even cleaner code. Tip number 2 is to stay away from GameObject.find. This is a very Unity specific tip, and if you need to find a reference to an object, it's really simple to type in GameObject.find, but this is not an efficient way of finding an object. This code checks the string inputted against the list of all game objects in the scene. If you have a very large scene with a ton of game objects, this can cause a slowdown if you're using it frequently, especially if you're using it in update. A better way to achieve this is by using GameObject.findWithTag, as this only looks through the list of available tags, which should be much smaller than the list of your game objects. You can also make the variable public and manually assign it in the inspector to get the same result. My final coding tip is to delete code that you don't need. When creating a new C# script, Unity fills in some things for you. Let's say you only need a start function, or you only need a method that's going to be called from another script, for example. Don't just leave a blank update function sitting there, go ahead and delete it. Also, if a word is grayed out, it means you aren't using that reference. When you create a new C# script, Unity places using unity.collections and using unity.collections.generic at the top of your script in the library section. Go ahead and delete these if you're not actually using anything from these libraries. And that's going to do it for today's video. I hope you got some value out of these optimization tricks I've learned over the years. If you enjoyed it, please give the video a like and share it with a friend who might find the information helpful. I also need to give a huge shout out to all my patrons who support TreeFall Studios on Patreon, and I got to give a special shout out to Carmen Red, LV, and Zach Ware. Thank you so much for what you do for TreeFall Studios on Patreon. If you stuck with me this far into the video, I've got another bonus tip for you. Also, when you're in Unity, make sure to delete out Unity packages that you don't need. Open the Package Manager window and click on In Project to see what came installed. Remove any of the ones that you aren't using. Be sure to let me know that you stayed for the bonus tip by leaving a comment down below that says, "Thanks for the bonus tip, whoopity doop doop doop." With that being said, I'll catch you guys in the next video.